All right. Good afternoon and welcome to this episode of Energy Power Play. All right. Let me just have a look, make sure we're all set up correctly and good to go. And we'll get started in just a few minutes over here. Luke, I can still see you. I'm changing the configurations here as this is our very first episode. We want to make sure that we're covering this off correctly. Now, what's interesting is trying to see exactly who's joining from the LinkedIn side. Looks like we have a few people on already.
I really appreciate you letting me be the guinea pig for kicking this off and trying this platform. I've done several in the past, but I've not used this platform. I'm pretty excited to see how it turns out.
Well, and the thing is, when you're doing things live for the first time, that's the tricky part. But assuming all is well, my only question here is I've opened a chat box here, so we should be available for anybody that wants to drop in a message at any point throughout the conversation, so we can engage with folks as they are logging in and out. With that said, again, welcome to Energy Power Play, and this is our official kickoff. This is the Sustainable Energy Leadership Series, where we aim to engage, educate, and inspire energy leaders. For those that don't know me, my name is Plaminotov. I'm a certified energy manager and a director at Rodan Energy. Rodan is a leading North American provider of distributed energy resources, asset optimization, demand response, energy intelligence, and metering solutions. And I'll be your host for today. And with me is our featured guest, Mr. Luke Shantz, founder and president of Arcadian Projects. Now, Luke is a seasoned construction professional with over 25 years experience in the commercial, industrial, energy sectors. Luke's passion for distributed energy resources has driven his work, helping businesses and utilities achieve clean energy generation, effective power consumption, and meet sustainability goals. With a commitment to sustainability, doing more with less. Luke's leadership at Arcadian Projects exemplifies the integration of impactful technology and practical expertise to address the climate crisis. Luke, thank you very much. It's a pleasure to have you on the show today.
Thanks, Plum. It's a pleasure to join you. I really appreciate you hosting and inviting me on the show, and I look forward just to sharing some knowledge and experience with our viewers and answering some questions.
Perfect. And now, when you send me the intro with a commitment to sustainability, I gotta say that word caught my eye a little bit, and actually, I've grown to like it quite a bit. So if you see me writing or saying the word sustainability at some point, I'll make sure to always give you credit for that one.
I appreciate that. It's a striking word that drums up conversations in lots of different spots. So.
Perfect. Yes, Anatoly, and we have you on. And yes, we can see that this is a chat window for the input. We see a message from Mr. Jeffrey Wall as well. So yeah, feel free to drop a comment or questions as we move along. Before we get into the top 5 technologies today, Luke, maybe just start off. Tell us a little bit about yourself. Where were you raised? How did you get into energy? Something along those lines so we get to know you.
I grew up on a farm just outside of Baden, about 15 minutes west of Waterloo. And I had my own farm for years. I worked in the trades as a millwright for 15 years, mainly in automotive and manufacturing sectors. In 2007, 2008, my buddy and good friend of mine and fellow farmer were just trying to figure out what do we want to do? How are we having an impact and what are we doing? And we decided, let's carve out and start our own business. We didn't exactly know what we wanted to do, but we knew we wanted to take our collective knowledge and experience from being in the trades on the farm and just apply it to something that had a greater purpose. So that kind of got us going. And then in 2009, the government launched the Green Energy program, which really gave us something to think about. And we just basically dove in with both feet and embraced that. And it was a good opportunity to start the company, start Arcadian Projects. And that was sort of how it evolved. And or it was four of us basically installing solar on our friends and families' farms and houses, and got going. And it was a great break from my past trades life, traveling all over Ontario, and it was nice to be just doing that and feeling good about it. And it evolved from there. We started taking on commercial projects, got hooked up with developers, and kind of just kept scaling and working through that over time. So that's how it kind of became the day. We were 70, now we're 70 people plus strong, with covering a bunch of different sectors with mechanical, electrical services, and focused on the energy sector, and being able to continue to integrate new technologies and fight the climate crisis. So
Amazing. And you know what? It seems almost like you got into that business by solving a problem for yourself and the community around you, which seems to be the perfect reason to get into any business. So yeah,
I hadn't really thought about it like that, but I have kind of adopted that mindset. I mean, get up every morning to build resiliency and create opportunities in our people and our customers and in our communities, just to keep developing the future. So as long as opportunities fall into that realm, it's fair game.
Amazing. And since we've met, so a few things that I remember about Arcadian. Correct me if I'm wrong on any of these, but from our conversation, I think some of the work that Arcadian's done, like there's a ton of installations for EV high-speed chargers all across Ontario. My guess is probably you've done hundreds of these installations. That's really kind of changing the landscape. I know Arcadian as well was one of the first companies in Ontario actually building out energy storage projects, which is also a very kind of innovative place to be. And to your very first point with putting solar on the farm, I always think of Arcadian as sort of the go-to company that has a ton of experience, putting solar on farms at municipalities, commercial, industrial facilities. So correct me if I'm wrong on any of these projects, but also maybe tell me a little bit about some of the recent projects that you're working on, and just anything else you want to add about Arcadian Projects as a company before we dive into the tech.
We've done. We started. I mean, obviously, a lot of impactful solar projects for all different developers and all different means, whether it's a microgrid application or following the government incentives, or net metering, behind the meter projects, working with the utilities on different opportunities. Battery storage, we kind of got into that, working with a manufacturer that was gaining a lot of traction. We helped them prove out their concepts and enclosures, and did a lot of pilot projects for them across North America, and it also gave us that opportunity to build the larger project, the 8.8 megawatt in Stratford, 40 megawatt hours of deployment. It was underneath a program, the ISO program, which really got our hands on and our minds wrapped around the technology, and we basically just got immersed in it, and really fought through some of those early challenges of the connectability and regulatory issues and code issues. So that really kind of ignited us on the battery front, and it's hasn't really, that whole sector has been an interesting transition and adoption of how that goes. We can talk about that. Yeah, I mean, we've done some cogen work, geothermal work. We've done modular buildings. That's something, if it's new and kind of innovative, and we find sometimes contractors will shy away from it, it's not tried and true, we'll take it on and try and figure out a way to work with the owner and the builder to deploy the project, right? So
sustainability.
Yeah. Before we get rolling, I had a question, and I know we're not live back and forth, but I just want people to think about something. About does anyone know or have an idea of the average adoption rate of technology in the energy sector right now? And you can just think about that and share it in the chat if you want to, of what that time frame, that window is, because those of us that are immersed in the energy, which is probably in the sector, a lot of us on the call probably as well. Sometimes we forget, right, how long we've been in it, and kind of lift your head up every now and then and look around and you wonder, how did it move forward and what was that time frame? So think about that, how long that time frame is something, and I wouldn't mind if you can just throw that number, what you think it is, in the chat. I'm talking about stuff like we're talking solar and batteries and EV chargers, and the time frame it's taken to adopt that and get it to commercialization and getting into the marketplace where developers and engineers are speccing it, comfortable with it. And while everybody's thinking about that, I'm going to just share a quote that really hit home with me when I saw it a few years ago. The technology exists today to help solve the climate crisis and the climate problems. Changing the human behavior might be our biggest challenge. And that's from Milford over at S2E Technologies. And when he said that, it kind of struck a chord with me. But I want people to think about that the technology's been here, it's ready to go. The funding for the technology is ready to deploy. It's the human behavior and the human mindset behind it that we're really, I think, our biggest challenges right now. So maybe set the tone for a discussion moving forward. I see some numbers popping in here. And what I'm going to say is what we've noticed on the technologies we're talking about is about a 10-year average adoption rate. Solar was launched, 15 years ago here in Ontario, introduced. It's been around forever, but it's taken us 10 years plus to get that written in new building specs, accepted by the code, accepted by, the regulatories. That's the window that we kind of see across the different technologies that we're seeing emerge right now, right? So we kind of base the new stuff we're going to talk about a little bit later, using that as a target and knowing that roadmap.
About 10 years.
Take a few years to get the ball rolling on that side.
And I see Michael here mentioned in the comments 17 or 18. So yeah, and it's interesting though, because I think you and I, when we first looked at a few different projects, and these were large scale utility projects, and some of them, from the time we started the conversation, from the time we looked at the technology, engaged the client, got proposals in front of them, till the implementation. I mean, the way I started to think, like when I looked at large scale energy projects, it really changed my perspective, because you realize that you may only have, let's say, 30, 40 big projects in your lifetime just because of the time to deploy some of this. So not just talking about like adoption, but also implementation. When you're talking about large scale code generation, for example, sometimes it's a 3 to 4 year project from the time everything is signed off, and then COVID comes and pushes it back another year or two. So yeah, very, very interesting. And you're right, Michael, very, very slow adoption rate in Canada for technology. And I think his comment,
Ontario specifically, right, is just, if we want to be honest with ourselves, we're still paying a very reduced rate for our electricity per kilowatt, right? If you look around the globe, and it's not fair that it's always a political bargaining tool, which frustrates me. But also our grid, right? We have a unique grid in Ontario with Bruce Nuclear and Niagara Falls, and so there's a few things that make Ontario interesting, which actually makes that time frame even more challenging and a little longer. So thanks for putting your comments in your chat.
Yeah, very, very good. Very good. Well, one last thing before we get into the technology, and maybe if you can do this, Luke, without giving away too many secrets, but when Arcadian goes to assess and evaluate new technologies, like what does some of that R&D process look like for you? And I know companies will set different criteria. Some is simple, some is very advanced. But what does that look like for Arcadian when you're on the hunt for the next big thing per se?
Well, for us, we like to have a little mix. We like to look at technologies that we know are 20 years out. Yeah, but we're really cautious about where we put our resources, right? So for us, finding that sweet spot of, because we're an integrator, right? So we want something that we can get out in front of engineers with and get them excited and add some value to doing that product research, and bringing sort of the hands-on experience that we see is going to take to connect these assets. A lot of times that's the biggest challenge. Technology comes out, batteries come out. This is great. We'll put them in a box. We're going to deploy them. Here's the use case for it. Yeah, we think there's a market. We're running the numbers. The developers run the numbers on what they can try and make work. But then there's big missing pieces and gaps on the actual integration of it, integrating it to the grid and the high voltage side. And so for us, evaluating those pieces on where can we add some value, with our past experience and knowledge, where can we help that technology? How can we shorten that time frame? So when we're evaluating a specific technology or product, a lot of that comes into it is can we make it work? Do we have customers out there that it can actually have an impact on? And does it meet regulatory? Are we going to run into a whole bunch of red tape on this, even though it's needed and called for? Are we going to run into challenges in red tape on, building code, ESA,
Right.
utility regulatory? So those are all, we'll be cautious, right? Because we know that those types of things take a lot longer to solve. So, but having the right mix. So what we want is some technologies that are maybe 5 years out that we can really get behind and build pilot projects and find early adopters for right away. And then we'll have some that are 10 years out. And then we love looking at some of the stuff that we know is going to be here in, 15, 20 years.
Amazing. And you know what? Depending on who's listening today, maybe you and I will invite some of our friends from the Ontario Energy Board and the ISO out and talk a little bit about regulatory and what we see on the actual ground versus what they may see on their desks when they're looking at different regulations and bills. So stay tuned. That could be a future episode over here. All right, very good. So let's dive into the top 5 technologies. So we've listed 5. It's by no means a super extensive list that I don't anticipate, and given the time frame, I don't see this being much of a scientific type of conversation as opposed to a more practical guide as to things that we should be looking out for that really have the potential to be game changers for energy managers and anybody else that's interested in energy. So with that said, let's dive right into it. You can start in any order that you like, Luke. Tell me about the first technology energy managers should be looking out for.
Well, in no real particular order, but I mean, it kind of depends on your sector too, right? If you're industrial manufacturing, there's certain technologies that are making a difference on large refrigeration customers and stuff like that. There's that, but so it depends on what you're doing. I'm just going to kind of randomly pick. I mean, we're seeing heat pumps. I don't really consider a new technology. They've been around forever, but we are seeing finally some uptake here, and I just wanted to make sure we mentioned that because we are seeing some traction, and we are getting them to a commercial scale now, where we're using ground source and a lot of air source hydronic systems in new commercial buildings and long-term care facilities, institutional. So it's nice to see that finally using that technology that's been around forever and actually getting it into buildings over here is kind of where we find is kind of our gap of our job is just getting that technology and getting it in front of engineers. So we've gained some traction with that. It's nice to see that moving forward on the heat pump side. We'll also have the funding and some grants that are pushing that forward.
Let me ask you on the heat pump front. So this is a technology that's been around for a very long time. It's not new. And just for some of our audience here, why is it gaining such rapid pace right now? What is it about the last 3-4 years? Is it the funding? Is it government regulation? Is it an eye-opening moment? Is it some kind of tech advancement that made this more affordable? In your view, why are heat pumps now ready to, or maybe even at that rapid rate of adoption?
A few things that jump to mind. I mean, obviously, we're driving decarbonization through, through all the different levels. So it's a kind of a no-brainer to be able to switch to that on that side of things. Is our carbon impact. That's what's sort of driving it to get that technology going. Another, the technology's improved. So I mean, in our colder climates and stuff, which is we haven't had the adoption here in North America because of we're heavy oil and gas continent, right? So that sort of delayed some of that technology moving forward, and then the availability and cost of that the natural gas, right? But I think driving the decarbonization is a big piece of getting people's interest in them understanding the technology and getting it in. And the technology's gotten better, so we can operate at colder climates. Some of the refrigeration code changes, and that's also driving it, where it's becoming a little more complicated. They're trying to push out some of the change the refrigeration rules and regs. Now the heat pumps still run, pumps on them. So, but those are some reasons I think we're gaining some traction, and they just gaining confidence. People are putting them in and seeing that they can operate at the temperatures that we need and get the savings that we need. So, and they do, they're adaptable to existing systems. So it's not like you're totally renovating a house or a building to tie it into your ductwork system. They are,
right. And perhaps there's something there to be said about at least in Canada, where we were sitting pretty firm on the carbon tax and what that could look like for the future, before the AXA tax campaign. But it seemed like the outlook of understanding the carbon tax impact to natural gas heating systems. I'm sure as folks were looking at these projects beyond the decarbonization scope, when you're looking at the financials, when you're modeling for carbon taxes versus heat pumps, there's a real financial gain, right? Because I think we found this generally, that decarbonization is great, but when we can decarbonize, we can make it environmentally sustainable and have it save us money. That's when things really work. So maybe something to be said there about the price of electricity and natural gas. Okay, sounds good. So heat pumps. You said you didn't want to spend much time on there. Fair, because I think we've seen a lot about heat pumps recently. What's next? What's the number two tech we're looking at?
I mean, well, hydrogen, I'm just sort of falling in a little bit of an order as they've been introduced over, the last 5 years. I mean, hydrogen is in prime discussions right now. It's currently being used to, direct inject into large diesel engines, mostly in transportation, and some natural gas engines as well. They're seeing the benefit of fuel savings there and carbon reduction. Basically, it's at that stage batteries was at 10 years ago, where they're trialing and seeing where they can gain some traction with it. But it's a complicated mix as well. It takes a lot of power and electricity to make the hydrogen, and again, with our renewable grid, it's we're well suited to produce it. We haven't really been involved directly with hydrogen projects that are launching, but there's several on our docket right now that are coming to fruition. Customers that are taking the leap and going to put the electrolyzers in and move forward with it for their particular processes that it works well with. But we are seeing that is leading towards like prime power plants. So we have to figure out how to bridge this gap as we electrify the grid and we deal with the grid resiliency and the challenge of the connectability of energy assets. As we do that, we're seeing prime power plants pop up, but there's a lot of thought going into them. When I say prime power, like a on-site generation for a private customer or a large manufacturer that just needs the grid resiliency to operate. They're taking a long look at putting their own plants in, and it could be a microgrid application. We've seen where there's some solar, there's actually a battery asset for acting as a UPS and also a generator asset. But those assets now, the technology is improved to a point where the engines are being run on pure hydrogen. They're being tested on pure hydrogen. So they're making some headway that these plants will eventually be able to operate with that asset and that infrastructure they're putting on hydrogen. Now, for the next foreseeable future, they're going to be running on natural gas, but we need the power. So it's this trade-off that I find very challenging as an integrator of renewable assets. I'm struggling with that I need to put generator assets and natural gas assets on to bridge this gap of being able to deploy more. Right. So it's a real balancing act, and really not every technology is suited for every purpose either. So
right. Yeah, and I think not too long ago there was in conversations with a few of the OEMs, they had looked at hydrogen, and I'm not sure how current or relevant this number is, but it was something like almost 5 times the price of them to run hydrogen versus natural gas. And mind you, this was a few years ago, so maybe the number is different. And then there's the logistical aspect of delivering clean hydrogen to the facility. So
it will get there. It's tying in great. Yep. Like, I mean, with RNG, right? We're seeing that whole picture of anaerobic digesters, collection of green waste, the facility plants. We've been involved with building several of them that are actually processing that waste, getting it to a digester, producing renewable natural gas. Like, that whole side of things is really interesting and starting to gain some traction. But I mean, we already have the infrastructure for natural gas, so it's figuring out how that integrates with each region, and and the provinces are all different too. So, but that ties into, if you can make hydrogen from RNG or from renewables, all of a sudden you can sort of complete that circle.
And isn't that the beautiful concept when you can take your waste and take something that you have on site already that's not being utilized and turn it into something productive?
It's coming. Hydrogen is right there, and there where solar was at, or like, just by talking to the people in the industry and the stakeholders, you can just feel the buzz is increasing and they're getting some traction. It's going to be interesting what that mix is going to look like, because it's not all one or the other. It's a real combination of all of these technologies to carve out our path forward. So
Perfect. All right, moving on. What's the next one, Luke?
we talked a little bit of prime power, liquid desiccant cooling, and it's just kind of really intriguing me right now. I'm kind of preliminary doing research and meeting with some companies about it and learning more about it. But it, to me, of the ones that I've been exposed to, has the greatest potential to have energy conservation impact. And it has tons of other benefits as well as indoor air quality. It acts as the main component is a dehumidification, right? So the liquid desiccant is like, it's been around for a while, but being able to apply it in a manner that in a commercial manner, and like replacing rooftop units with a large unit that can actually pull all of our air, especially in Ontario here where we have a lot of humidity. Drastically reduces the consumption of energy to, once you get that the dehumidity out of the air, it uses a lot less power to do the cooling piece. So it's going to be really interesting. But they've got some test models running, and I've looked at some of the data that they're producing from it on the energy consumption side. It's just drastically reduces the electricity consumption, and it works well with the load times of your grid, like load displacement, which is what all the new incentives are based around. So it's interesting that it falls into that category of when the load is the highest in the grid in the afternoon or the hot afternoon, and you're using the most amount of power on our traditional rooftop units to dehumidify the air before we cool the air, before we put it in the building. This one here uses virtually no energy to dehumidify, and then so it's before you actually cool the air. So without going into a lot of the tech and science behind it, if you get a chance, take a look online and do some reading on it. It's a very interesting topic, and they're
Liquid
getting
desiccant cooling. And what types of energy efficiency savings are they modeling? And I'll say modeling because this one is still seems to be pretty early on in terms of commercialization. Is there a number roughly? How much more efficient is it than your conventional rooftop unit?
Well, just to give you a bit of an idea, they say it's like three times, uses three times the less energy to do the dehumidification process, right? So that's where a lot of the savings are on the front end, is effectively removing the moisture from the air is three times more efficient than the current ASHRAE standards. It's a game changer, and I'm still in the early stages of learning a little bit more about it, but I'm anxious to get my hands on one and learn a little bit more about it, because there's a lot of applications for it, and it's another one that's fairly simple to integrate and switch out, right? So I mean, the infrastructure and the ductwork and everything is there in a lot of these facilities that could use it. They're not starting from ground zero, and you're not tying in, you're not relying on grid connection and that either, right? So it's more on the conservation side, which I love those projects because they're a lot more cost effective with a better ROI when you're saving power than when you're trying to generate it.
Right. And you mentioned it has some benefits for air quality. So it seems like this would be on the residential, multi-unit residential, commercial space, maybe even the education institutional space could be something to look at. And there we go. If anybody's looking to test liquid desiccant cooling, Luke and Arcadian are more than happy to support that test and bring this technology to Ontario.
Well, if you're interested, shoot me a note, shoot me a private message. I can send you some links that'll really explain it really well.
Excellent. Very good. All right. Let's move on to the next one. What else do we have in mind for top energy technologies?
One we've been working with right now and putting it in a couple of our systems is like phase change batteries. You're going to start to
Mhm.
see a theme here. All of these things have been around for a very long time, and simple concepts, but getting that right component, that right gel, that right, scientific um, product that does it really super efficiently. And they've made a lot of headway on this front on the phase change material. It's used in all kinds of different applications. We've seen effective buildings using, ceiling tiles with it that actually you're using and moving existing heat in a building. So, and you're storing it and releasing it when you need it. Again, I'm not going to go into the science behind it, but we're seeing a lot of traction with that, and there's some companies that actually have some really good units. They're calling them batteries because you're basically pulling the energy and the heat from one area of your building, storing it, and deploying it when you need it. And it covers a wide array of usages. I mean, a real simple one is basically replacing a domestic hot water tank,
Mhm.
right? And it can store energy for way longer than well, it can store it at all different temperatures and then release it. You just sort of decide what temperature you need it at, but it can collect heat from all different areas. So on your exhaust heat from your building or on your reclaim loop. But there's a lot of potential for integrating these batteries, and they've come a long way on making them super compact. I
Mhm.
don't know if you're not familiar with phase change. The thing that clicked in my mind when I was a kid, my parents bought one of those hot packs, and you could get them, and they're still around. I think my parents are still working and still using them. But you have that hot pack, and it's got that little dime or that penny in it, and you click it, so you heat it up in the microwave, and you that's where you get your heat from, and it turns to a real liquidy gel. And whenever you need it, you can click that, and it will phase change material into heat. So it'll be stored at room temperature. When you need it, you can open it, and the chemical reaction will deploy the heat, and it stays like,
Mhm.
it's crazy how long it stays hot for, right? But so it's
Yeah.
being used in tons of different applications in different buildings, but mainly in like hydronic systems and loops like that. um, Residential scale, it's a no-brainer when you're incorporating it into your domestic hot water loops and stuff. Commercial scale, it's starting to gain some traction on all different fronts. And again, it's a good load displacement technology, and it's not costing you any power to charge the batteries, right? Or the
Mhm.
component, right? And then you release it, so it's a passive technology that's
And that's exactly what came to mind. With Rodan being in the peak displacement and managing peaks for our jurisdictions, when I looked at phase change batteries and seeing that they can store heat with negligible, almost no losses for a number of days. That is something pretty amazing, right? Because you can take that, you can store it, and only use it when you need it. And it seems to also be a very nice complement to any other renewables that you would have on site, because once you take from heat from your solar generation or whatever that may be, you can store it and use it when it's needed without really any losses. So
well, the
that's
main the main thing about it is it's endless. Like it can cycle unlimited amount of times. It doesn't the product and the actual gel, if you will, for lack of a better word, won't it doesn't degrade, right? So
right.
you can use it for over the life cycle on it is really long. So
Incredible, incredible. All right, phase change batteries. There's your overview. All right, let's get into a few more. We're doing pretty good on time. It's about 12:30 right now, so let's get into a few more technologies.
ones that we're being asked for right now by some customers, and ones we see that will make sense. They've been around for a little bit too, like your solar battery light standard,
Mhm.
right? Again, pretty simple, using technologies that's been around for a long time, but now they've come up with a commercial product that is being deployed all over on utility scale projects, on roadways, on different things. When I was over on a mission trip in Africa this summer, I paid attention to a lot of that, and it's interesting. Like they've adopted some of these technologies as well, because cost of power and infrastructure over there. So it's kind of neat to see a very simple technology like a light standard really having an impact in all different parts of the globe, right? But even here, the technology's come a long way. So they're actually now the early ones were they look like a big airplane. They got a big, huge solar panel on the top of it. They got a big, huge square battery at the base of it, right? But now that the uptake is happening, they've got a really sleek looking pole that's actually wrapped with flex solar. So the whole pole is wrapped all the way up, and inside the pole is a lithium ion battery up to like 90 kilowatt hour batteries inside these poles. So it's not just a light pole. So now you're using this asset. It's independent and it's got live power on it all the time. It can run for days without even the sun charging it because of the battery size. So it's not just producing light. They're running their security cameras off of there. They're running their network off of it. It's so providing internet and stuff. So it's interesting how they've taken it and really made it quite aesthetically pleasing, and it's getting adopted even in North America. It's being used by utilities in certain regions for cost savings and lots of other reasons.
So you've got these old light poles that we're all used to that are down the street. This is basically just one big pole and a light at the top. And what we're talking about here is an actual battery in an asset that does more than just provide light. So it has a battery that you can use, that you can plug your EV charger in, I'm assuming, for curbside EV charging.
Yeah, you can. I mean, obviously the charger would empty out pretty quick depending on what your use case is. But if you're doing like a complex, they can be different. Some of them have batteries in them. You can have light standards that don't have batteries in them. You can have ones that have communications on them and security on them or not. So you can kind of build your own pole based on the complex that you need it in. But that's a lot of storage. It's a good sized battery inside that pole. And I don't have the specs in front of me, but there's quite a, with the wrapped pole and solar, it still produces a ton of power.
Interesting. And when I was doing a bit of reading before our conversation, I saw a case study. I believe this was in Seoul, in Korea, where they had implemented a number of these, and they were using it to charge drones at the top of the of the pole, and the drones would be used for, I guess, security or whatever else. They would have lights attached to it, and they would also send Wi-Fi signals, so that, let's say you're at a park and you have a light pole for, your safety at the park. Folks that use the park can go next to the light pole, and they have high-speed internet, Wi-Fi directly from that unit. And they're also integrating with some other interesting pieces like smart crosswalks to help people, cross the street a little more effectively. But interesting. I know there was a lot of talk about this smart city initiative in downtown Toronto. We're having, a lot of sensors and cameras connected to a specific district in Toronto. I'm not sure how far along that's come. There was a lot of talk on it before, but this seems like a technology that will fit right into that type of scenario, where you have data points, you have visibility, and you have this interactive sort of interface on what used to be just a light pole.
Yeah, and that's what we're seeing, right? A lot of the work that we are getting involved with is gearing towards smart buildings and autonomous buildings, right? Where you have the interactive network and assets, and it's pretty cool to see it finally getting some traction, and it's going to evolve over the next 20 years, but starting to get some of these technologies spec'd by the engineering firms and accepted by the architects, and get them in, the ones that can actually have a real impact on the energy and the operations of the building, and the indoor climate and indoor air quality for the people that are there. So it's cool that smart building that we've seen is not as far out as what we might think.
Right.
And POE lighting is one that was kind of on our list. I mean, again, It's been around for a while.
And POE meaning power over Ethernet.
Yeah, power over Ethernet lighting. It's come a long ways. We're seeing it now spec'd in projects. We're putting it in some office scenarios where you want the ability to have that control on daylight harvesting and things in these large complex. but it's the prices coming down. There's a lot of advantages to it, not just the energy consumption side, but also that finite control of having that indoor climate safety and comfort for the people that are working in the building.
Mhm.
Is pretty awesome. But also there's savings on it's all run data cabling, right? So you're saving on that upfront electrical costs and conduit and power from the distribution side and trades labor, right? So it's being done by the datacom teams, and there's some cost savings on the install side of it too, and it ties in basically anywhere to the network. So
Now, for this technology, like when you get to the end of the cable and you have a light fixture, does it have to be, I guess, configured to take this type of current? Like, can you just plug it into any type of light fixture, or does it need to be PoE compatible?
yeah, no, it's a separate fixture, right? It's
Yeah.
it's a separate low voltage fixture that it basically you run datacom to it, and it's run off of it's powered through the network.
Hmm.
So you're not running 120 volt power or 347 power to your fixture. You're running it on the low voltage side. Now they have limitations, obviously, right? I mean, if you're in warehousing and stuff like that, you have to think about you don't want to have all double the amount of fixtures in there, because they are limited to the driver size and the lumens that they can put out, but
Hmm.
because of the voltage. But they have a lot of really reasonable applications in office scenarios and labs and institutional buildings and that. So we're seeing lots of traction on that, and it's just again just an awareness thing, and
Right.
getting engineers and architects comfortable with knowing the products out there and getting it spec'd, educating them and getting them comfortable with it, and knowing that it's readily available. So that's something we've been working on with another team of ours that's just basically solely focused on shortening the time frame of getting these technologies into the marketplace, because that's the biggest hurdle that I see right now.
Right. Shortening the time frame to actually put these technologies that we know work and are effective and are efficient. Yeah, that seems to be the theme here today with when we're looking at any of these technologies, Luke. Now, as we had our list, is there anything else that comes to mind? I think we've gone through the five that we had outlined. Is there anything else? Like I know battery storage is one that we're talking about quite often. We talked a bit about thermal storage. Anything else that you feel we've maybe should have touched on but didn't put in our initial list, or should we leave it here for now?
There is like so many, but it's just like these are some of the ones that I see moving forward. Um, we're working on lots of, I mean, there's a big focus on
Hmm.
modular construction and technology going into the modular builds to address the housing crisis and stuff like that. It's, maybe a little bit outside the energy realm, but we're seeing a lot of
Right.
funding and incentives for figuring that piece out. Um, yeah, there's like wouldn't even know where. Like there's a really cool one
Right.
we're looking at right now that it's mostly on indoor environment again, and safety. There's a really cool technology that's making waves south of the border. It's um, puts out a UV light, so it's all mounted in a room, say in a hospital or whatever, or a waiting room or a lab or an office, and it will actually detect motion and detect people and detect how long people are at a certain station and occupancy, and then they'll leave and go, and then it will automatically deploy and a concentrated UV light on those surfaces and kill off um, germs and viruses and stuff. So it's pretty neat watching that. And then they
Right.
operating in live. They've got it, out there. It's sort of one that we've came across that stuck out and was like pretty cool. And it's having an impact on indoor climate
Indoor air quality.
and safety.
Yeah, and it seems like now with big data, connected buildings, smart buildings, where we're able to gather easily and fairly cheaply with different signals, I think that's where also we're going to see a lot of different uptake. Okay, very good. So these are the technologies, Luca. Fascinating conversation. Again, we're really happy to have you on. We do have a bit of time for folks to stay until
Did you see any questions? I'm not can't see the screen to see if there's any questions that came in that are relevant and we want to address.
There are a few.
Hopefully people are taking a few things and maybe challenging each other and talking back and forth too. So it's a new platform for me. I can't see what's all going on behind the scenes, but
Yeah, from going back to the beginning of our conversation, slow uptick in adoption here in Canada echoes exactly your sentiment and what you've seen here. Jeffrey says big uptick in heat pumps here. And Jeffrey, I believe Jeffrey is in New York with electrification and carbon mandates. And the question, some of the chatter happening in the chat is it a need? Is it economic benefit or political agenda? And those are some of the conversations happening here.
Everything that gets sucked into the political agenda just really frustrates me, because there's such good tech out there that can have such an impact, and he's not wrong, right? Why is it the uptake here, right? So
yeah.
But yeah, one thing on the battery side, we didn't really get too into detail, but it is gaining a lot of traction, and I really like the way some of the new incentives are structured here in Ontario on the load displacement side of things. It's really got people thinking about how do we address that concern of the provincial peaks and that peak demand that we're trying to address. And I think they've structured some of those incentives in a way that's going to force people like us to do the design a little bit differently, and maybe try some different technologies that we may not have thought of before, as far as just filling the roof with solar and producing kilowatt hours. Well, this is the problem we're trying to solve. So I like what they've done there, and I think there's some inventive ways we can work on integrating both batteries and different things to address the load displacement side of things. And they're also getting a lot of traction on the residential side. So
enabling grid flexible buildings and assets as we electrify and have to manage our peaks a lot better is going to be critical. And yeah, I'm glad to hear that that's being addressed in some of the incentives that we're rolling out in Ontario. And maybe that will make a good future session as well, is an overview of what's up with these incentives. But maybe that's one to wait for, post elections to make sure that the incentives have some good legs to stand on. But the intent is clear. Grid flexible assets and supporting peaks is very, very important.
Well, I'm going to just tell you, I know we're kind of up against the time, but if people stay on to listen to my story, they can listen to it or not. But one thing I was thinking as I was talking, because back to this adoption rate thing, it really got to me about a year ago. And I was kind of at my wit's end, like, when are we going to move some stuff forward? And then I got a call one afternoon about a year ago, and it changed my whole way of thinking. It's kind of when I came up with this 10 to 15 year range, and really evaluating on what's coming in, shortening the time frame and getting stuff to market. And it was a developer. I got a call. We designed a net metering system about 10 years ago for a client, and they were on board, progressive early adopter of we're going to design a net zero commercial facility. It was a big dealership. Geothermal base load and everything, no gas, offset all their electricity consumption on an annual basis.
Yep.
And this was 10 years ago. So I'm like, yeah, we're all over this. Let's do it. And we dove in with our design team. We made it all work. Priced the whole project, and we got, there wasn't a crazy payback, but it was still in around that 10-year payback for the entire project on their on all the additional energy assets. So they're good. Management team's ready to move forward. Leadership team gives us the green light. They're like, we need to do this. It fits well. Long-term thinkers. And then overnight, the builder was involved and basically talked the building owner and the company owner out of these. You don't want to do this. And this is just one reason after the other why this just is not a good thing to move forward. Really got my mind turning on how far behind construction is. But that owner basically pulled the plug on the whole thing after everything was ready to go. He got scared, got cold feet, pulled the plug, and built a traditional building with rooftop units and full gas service and bid spec building. And it wasn't, just long story short, 10 years go by. I get a call, and it was, this guy's like, yeah, you know what, we need, and I recognize the name on my phone, and he introduced himself. I'm like, he didn't remember talking to me or that I was involved with that project 10 years ago. But Luke, we need to get solar on this new building. I'm building a new complex. It has to have solar. It has to have this. And he's like, we need to make this an energy efficient building. We need to, and I kind of like, I almost dropped the phone. I'm like, do you even remember having a conversation? Because he was very adamant. This is never going to take. We can't do this. And here he is on the phone telling me how excited he is about having to get involved with this project and do that. And I just was, it was just basically an aha moment for me to go, okay, this is the journey we're on. And we're out in front of this journey, and we're deploying this, and we're very familiar with all these things. But the general public in the construction world, the engineering world, we need to come take a few steps back and bring them on our journey and really buy in. So that's just a story that is stuck in my head of where I came up with this mindset of how long it takes to get these technologies to market. And I became a lot more at ease. I'm like, okay, it's all right. We're on this journey. If it's 10 years, it's 10 years. But we're on this journey. What am I going to work on next that's going to be mainstream in 10 years? And that's sort of what drove me to kind of be very strategic on what we're working on to drive forward and what can have the biggest impact. So that's just a story that kind of stuck with me. Help me think about the adoption rate of this stuff.
You know what though, with that said, I think it's a very positive story as well. So you were ahead of it at that point. The project was squashed, but now maybe this is a signal of the market coming to that moment where we knew this made sense 10 years ago, but now, the market sees that it makes sense. So that to me is a very positive light, and I hope that project does go through, and this is moves forward.
Well, I can now see some of the chatter on the side here. I noticed John Rose put a comment in here, and he's bang on. It's still very frustrating. I didn't want to get into a political risk discussion, but it is. Right. I'm seeing some other comments here from Jeffrey and Anatoly as well. It is a big challenge, especially in Ontario here, but in other regions as well, is the political risk that goes along with it all. It makes it challenging to get investors involved and excited about this. But appreciate everybody tuning in and everybody putting some comments in here. Hopefully I can get to read through those in a little more detail, and feel free to reach out. I'm happy to share any information or links or info I have on. Pass it along.
Excellent. There's another comment about AI and an anti-green man down south. I wonder who this is about. How would these two affect efficiency industry? Time will tell. And I think a political discourse and how that affects the energy industry as a whole is going to happen. But to your point, Luke, it seems the technology, the market, and the economic benefits are here. These are no longer futuristic projects. These are things that are in many times being implemented in other places of the world that we're just need to line up with and finally just say, hey, this makes sense. Let's do it. For example, I talked to a few folks from the Netherlands at a greenhouse conference, and just a brief conversation. And they said, we came to Canada. We drove through Toronto, and we don't see hardly any solar panels on homes and on buildings. He goes, where we're from, almost every home has solar panels. It's built into code now. You can't build a new house without having a solar system. So yeah, a lot of what we're talking about, in other places is already mainstream. But this is why we need these conversations and folks like Arcadian Projects, like Rodan, to continue the conversation and the push towards solutions that actually make sense and are effective, are efficient, and are going to leave us in a better position for our future. With that said, I appreciate everybody here. Just one last comment we can address, and this one is from Anatoly. It's directed towards you, Luke, so I'm going to point in your direction. Without abundant, near free renewable electricity, H2 is cost ineffective, as I learned in different sources. With near free renewable electricity, batteries are cheaper. Do you assess the situation differently?
Batteries are cheaper? I'm not sure I quite understand the question. I thought it was originally. So maybe the question is, because of our low cost of producing renewables, Anatoly, Anatoly, I'm happy to chat after you and I we owe each other a catch up anyways, but I'm happy to maybe have a call after this, Anatoly, and maybe get what you're at. here? I'm not sure I understand the question.
Yeah, let's do it that way. But yeah, as we wrap it up, appreciate everybody joining on today. Luke, appreciate you for being the first one onto the Energy Power Play series. Next episode is going to be in 2 weeks, where we'll be talking about SMRs, micro nuclear small modular reactors. Kind of the history, where we're at, and what that spells for the future. Luke, would love to have you on again on a future episode as well. And as we promised, we'll go through our attendee list, and Luke and I both agreed to actually give away a book. I know my book that I'll be giving away, it's not tied to energy, but it is Dr. Martin Luther King's A Testament of Hope. And I'll be sending this to one of our listeners today. And Luke has also selected a book which is spelled, I don't know if the audience sees it backwards, so you might have to tell us what the title is.
What We Owe the Future, just really, it's a difficult read and a challenging read. It's kind of mind bending, but it changed my perspective on things and what we do now and how it affects things, not just 50 years, 100 years down the road, but 1,000 years down the road. So it's a real bit of a mind bender, but it's really changed my perspective on some things. So it's a good read.
Perfect. So we'll be sending those out to. I'll be sending away one book. Luke will be sending away one book. We'll pick folks randomly. So if you get a note for it, please notice not spam. We are sending out these books for you. With that said, we'll wrap it up here. If you enjoyed this or you'd like to see the recap, the Energy Power Play newsletter is live on LinkedIn as well. So we'll be posting a recap of this conversation, and also it'll be the perfect place to stay up to date for future developments. Feel free to reach out to Luke or myself at any point. We always love talking about energy innovations, and sustainovations, as is my new word for the week. So thanks, everyone. Thank you again, Luke, and have a wonderful day ahead.